All right, number 5, I graphed these points. The points they gave me were 1, 1, right? So like right down here, 1, 1, 4, 5, 16, 10, right over here, right? And then what I did was I counted how much am I going over. I'm going over 3 and I'm going up 4 to get from one spot to the other. Or I could say from here to there, right? I've got to go down 4 and to the left by 3. So over here, I'm going to do the same thing. So I'm going to go down 4 and I'm going to go left 3, right? And so that took me right to this point. So down 4 from 10 is going to get me 6 in the Y direction, and back 3 in the X direction is going to get me to 13. That's how I got this other point right here. So the correct answer was 13.6 on number 5. On number 6, it tells us the max that this angle is going to get to is 115. So let's put 115 right in here. Once the lift is completely stretched out, there's 115 here. And then this angle is supplementary with that 115. So 180 minus 115 gives us 65. So 65 is the answer on number 6. On number 7, we have, this figure here, and it tells us that we're looking for MNJ. So here's MNJ. This is a vertical angle with this 50 over here. So 50 is MNJ, lines up directly with that number right there. Then it wants us to find MJN. So MJN, this one right here, right? And I think there's a couple ways that we could do this. One way is we know this is 50, right? And the sum of the interior angles is 180. So if I've got 180 to use up and I've used up 50 already, I'm down to 130, and I've got to split that 130 between these two angles, because this angle right up here is the same as this one down here because the diagonals bisect each other in a rectangle, and they're also congruent to each other. The rectangles diagonals are equal to each other. So then I know that this is each 65. So MJN is 65. And then MLN right here is the same as this angle right here, because these are alternate interior angles. So if I've got 90 here and I used up 65, that would give me 25 for this angle. So this angle must be 25 right up here. So we got 25 for that blank right there. And just putting the drawing down and kind of marking it up like I'm doing right here is the work that I'd like to see. Pair of base angles in an isosceles trapezoid. So you notice I marked the sides equal to each other. And then it says a pair of base angles in an isosceles trapezoid have a measure 2 times x minus 10. So that means this one's 2 times x minus 10, and this one's 2 times x minus 10. Those are two base angles that are equal to each other. And then down here, we got 4x plus 8 and 4x plus 8 for these two base angles. So you could add them all up and set equal to 360, or you could add up 2 of them and set equal to 180, because consecutive angles in a trapezoid are supplementary because they're same side interior angles between parallel lines. So I added them up, set equal to 180, and then did my algebra. I got 32 for x. On number 9, it says PQRS has vertices like that. So what I did was I graphed the trapezoid on just a quick little, hand sketched x and y axis. So this is my y axis, this is my x axis, and I want to put 0, 0, 0, 4, 12, 0. This is 12, 0 out here, 12, 0, right? 0, 4. And then I want to put 6, 4 right up here. So 6, 4. And you notice like this one's coming up 4. So is this one right here. It's coming up 4. So this side is parallel to this one. These are the bases. The ones that are parallel are the bases. And we're going over 6 from the y-axis. We're going over 6, right? So this length up here is 6. And then this length down here is 12, right? So how do we find the mid segment? Well, we add the 6 and 12 together. So plus 6, that's 18. And then you divide that by 2. And so 18 divided by 2, half of it, or however you want to think about it, is 9. So that's the mid segment right there. So 9 goes here. Oh, we better put our answer up here. This was 32. And then this one was pretty tricky. It says kite WXYZ. So you make something that looks like a kite, and you just start at one of the vertices, W, X, Y, Z. You just go around the shape. And then it tells me that 90 and 40 are two of the angles. And it says that this is Z and that's X over there, right? And so that means that these two angles that they just told us have to be included between the equal sides, because the non-equal angles are between the sides that are equal to each other. I don't know if that makes sense or not, but the ones that are equal to each other are between the sides that are not equal to each other. So what I did was I took 180. Oh, let me back up for a second. I didn't do that. I took 360 and I subtracted 135 from that, because I subtracted 130 from that, because 90 and 40 make 130, right? So 90 plus 40 is 130. So I'm taking 360 minus 130 and I get 230. And then I divide that by 2, because it's got to be equal amounts between this angle here and this angle over there. So I took 2 into 230, and that gives us 115. So 115 over there, 115 for that angle right down there. So 115 on number 10. On number 11, the diagonals of a parallelogram bisect each other. So we're going to set 2z plus 7 equal to z plus 9, and we're going to solve for z. So I subtract z from both sides, and I get z plus 7 equals 9, and then I subtract 7 from both sides, and I get z equals 2. I got to be careful. Are they looking for z? Yeah, they are. So I just put 2 down. And then we do the same with the y. We go 3y minus 5 equals y plus 5. I subtract y from both sides. I add 5 to both sides. I divide by 2. Y comes out to be 5. On this problem here, I'm going to set the opposite angles equal to each other. So 5y minus 9 equals 3y plus 11. I subtract 3y from both sides, and I get 2y. I add 9 to both sides, and I get 20. And then I divide by 2, and I get 10. So y is 10. And I do the same thing with the x's, and I get 10 again for the x's. So 5x plus 29 equals 7x plus 9. If I subtract 5x from both sides, if I subtract 9 from both sides, divide by 2, I get 10 for x. All right. Number 13, we look at this and go, well, what can we do? Again, consecutive angles are supplementary. So I'm going to go 3x plus 9 plus 2x plus 11 equals 180. I get 5x plus, that's a plus right there, plus 20 equals 180. I subtract 20 from both sides, and I get 160. I divide by 5, and it goes into there 32 times, I think. 32 for my x value. And then for my y value, let's see, I could plug the 32 back in for x. This is one way of doing it. And I get 62 plus 11. So I get 2 times 32 plus 11. So that was 64 plus 11, which comes out to be 75. And then I'm going to set that equal to 3y. And then I divide by 3, and y comes out to be 25. Okay, so y is 25 because the opposite angles are equal to each other. So these two consecutive angles equal 180 degrees. Opposite angles are equal to each other. Number 14, the last problem. This is a lot for you guys to hang on to. There's a lot of information in this test, right? So don't beat yourself up. Like if you got a little lost and didn't do all that well, I appreciate you just following along on the corrections and doing your best. It says CDB is 6y. This angle right in here is 6y. And it says ACB is 2y plus 20. 2y plus 20. Well, the diagonals in a rhombus bisect the angles. So this angle right here is 2y plus 20 also. You could say this one is 6y. And so we've got 12y down there, and we've got between these two, we got 4y plus 40, and we're back to that supplementary idea. These two added together equal 180. So let me put plus 12y right below this guy, and I get 16y plus 40 equals 180. So I'm adding up all the parts here. And if I subtract 40 from both sides, I get 140. If I divide that by 16, it goes into there 8.75 times. Now, this one was weird because it's a decimal, and it could throw you off, right? You're like, wait a minute. I haven't had a decimal the whole time. Did I make a mistake? And, sometimes that's just the way it goes, that, you get decimals, and other times you have whole numbers. A lot of them are whole numbers. Tests, are often made that way by the publisher to make it a little bit easier on us. But hey, thanks for watching all my corrections, and I hope that makes sense now. If I went through some problems too fast, call me over and I'll help you out. Thank you.